Hi everyone, and welcome back to this channel. Today we're going to be looking at static and dynamic array. So this is the 6th video in this series. The array data structure is one of the most important data structure in computer science, and we use it a lot. In this video we're going to be looking at what is an array, what is a static array, what is a dynamic array, when and where are array used. Then we will move down to static array usage example. We're going to look at dynamic array implementation details, and finally we'll look at dynamic array code implementation. So finally we're going to be building dynamic array from scratch. What is an array? An array is a collection of elements placed in contiguous or consecutive memory locations and are indexable from a range 0 to n-1. So think of an array as a container that contains elements arranged consecutively. So there is a word that might sound complex here, which is the word indexable. What is the meaning of indexable? This means that each position or slot in the array can be referenced with a number. So each position in the array, can be referenced with a number. 0 means a position, 1 means a position, 2 means a position. So that is the meaning of the word indexable. So by the time I give an example, this will be much more clearer. What is a static array? A static array is an array with a fixed length. So this means that once you declare the size of the array, it cannot change. If the array size is 5, it can't change to 2, it can't change to 10, it will always be 5. What is a dynamic array? A dynamic array is an array with a variable length. So this means that the array size can change. If the initial array size is 5, it can change to 6, it can change to 10, it can even come back to 4 or 3, right? So the array size can change. The array size, the size of a dynamic array can change. When and where are array used? Array are used nearly everywhere. In fact, from my experience, you can hardly find a code base without the array data structure. So the first usage is storing and accessing sequential data. This is the basic use of an array. So a building block for other data structures. Examples are linked list and stacks. So you can use an array to build other data structure like a linked list and a stack. So the third usage is storing objects. So you can use an array to store objects. Well, if you're a programmer already, I believe you should be familiar with this. So another use of an array is it is used by IO routines as buffers. We use an array as buffers to store information from an input or output stream. So suppose you have a really large file that you need to process, but that file is so big and it can't fit all in memory. We use a buffer to read small chunks of the file into the array one at a time, right? And so eventually we are able to read the entire file. An array is also useful for lookup tables and inverse lookup tables. So due to the indexing nature of an array, you can use it as a lookup table. An array can also be used to return multiple values from a function. So most programming languages allows you to return only a single value from a function. So the hack is to use an array. So you return an array, right? And the array contains the values, the multiple values that you want to return. So the seventh usage of an array, according to this slide, is a bit advanced, right? But it is still an array is still used in that sense. So an array is used in dynamic programming to cache answers to solve problems. So a dynamic array is a programming technique where you break a large problem into sub problems, right? So you can use an array to cache the answers to those sub problems. So an example of this kind of problem will be the knapsack problem or the coin change problem. Static array usage example. So let's look at how you can use a static array. This is an example of a static array. So the first table shows the elements, while the second table shows the index of each element. So elements in an array can be referenced using their index. So to reference 74, you have to use index 0. To reference element 12, you have to use index 2. There is no other way to access elements in an array. You can only access an element in an array using its index. There is no other way. Indexing in an array is zero based, meaning the first element is found at index 0. So the first index in an array is 0, not 1. Okay, so this can be a bit confusing for those new to programming or those new to computer science at large. So the index of an array always starts from 0. Okay, not 1, 0. Operations on a static array. So what are the operations that we can perform on a static array? We have access, we have search, insertion, appending, and deletion. So let's look at each of these. Accessing an element in a static array. So we access an element using its index. So we've discussed this earlier, right? So to access 74, you have to use index 0. To access 45, you have to use index 1. So once you know the index of that element, you can always access the element. So a question might come up in your mind that what if you use an index that is out of bound? Okay, so for example, you use index 30, right? So the compiler is going to throw an exception that the index is out of bound, right? So most compiler is going to throw an exception. Okay, the access time complexity is constant, right? So since you are just performing a single operation, you are inserting the index and you are getting the element in the index, so it is just a single operation. That is it takes a constant time. Searching for an element in a static array. So let's assume you want to search for 10 in this array and you don't know the index, right? So what you're going to do is to start checking from the beginning. Okay, so you check, is this 10? No. 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 Is this 10? Yes, right? So you finally found 10, right? Okay, so to get 10, we have to check each element in the array. Okay, so we started checking each element in the array before we could find 10. So the time complexity is linear. Okay, where n, right, n is the number of elements we checked before finding 10. Okay, so the search time complexity is big O of n. Insertion of an element in a static array. So this operation is not possible for a static array. Why? A static array has a fixed size, and if you insert a new element, it's going to increase the size, right? And remember, the size must be static, it can't change. So insertion is not possible for a static array. So the time complexity for this operation does not exist. Same thing goes for appending an element to the end of a static array. If you append an element to the end of a static array, that's going to change the array size. So this operation is not possible because the size must be fixed. deleting an element from a static array. Okay, so since the array 2 is static, if you delete an element, it's gonna change the array size. So if the array size is 5 and you deleted an element, that's gonna change the size to 4, right? So we don't want the array size to change, so it must be fixed. So this operation is not possible for a static array. Setting a key in a static array. So we can set a key at the index of an array using its index, right? So for example, if you're going to change the element at index 0, let's say you want to change it to 3, you're going to use the index, right? So this is going to change to 3, as you can see in the green box. So another example, let's say you want to change the element at index 5 to 40, right? So you change the element at that index and it changes to 40. So the time complexity is constant, so it's just a single operation. You are just setting a key. This is kind of like a declaring a function, okay? Declaring a variable, sorry. So dynamic array implementation details. A dynamic array can grow and shrink in size, right? So for example, the initial size is 2 in this case. If you add 4, the size is going to change to 3, right? If you add 9, the array size is going to change to 4, and if you remove 4, the array size will change to 3, right? So the array size is not fixed since it's a dynamic array. Okay, so how can we implement a dynamic array? Okay, one way is to use the static array. This is not the only way, okay, but one way is to actually use a static array. So this is the detail, right? So create a static array with an initial capacity, add elements to the underlying static array, and keep track of the number of elements. Okay, so if adding another element will exceed the capacity, create a new static array with twice the capacity and copy the original element into it. So this is a whole lot of information. Let me show you an example. So let's create a dynamic array with an initial capacity of 2. So this array size is 2 and the array is empty. So you let's say you added 7, right? Then you added 10. Now the array is full. The array is full, right? So let's say you want to add 3. Okay, so there's no more space for 3. So what are we going to do? So the solution to this is to create a new array twice the array size and copy elements in the previous array into it. So this means that you create another array twice the initial array size. So in this case, the array size is 2. So we're going to create another array which size is 4, right? So we double the size. Now we can add 3, okay? So let's say you added -2 again, and now you want to add 5, okay? The array is full again. So what do? We double the size, right? So the array size before is 4. We're going to increase the size to 8, okay? So now you can add 5. Operations and their complexities in a dynamic array. The access and search operation time complexity is the same for both static and dynamic array. So the access time is constant for both dynamic and static array, and the search time complexity too is linear for both the dynamic array and static array. Inserting an element in a dynamic array. So assuming you want to index, you want to insert 17 at index 3. Okay. Now note that there is another element at that index which is 89, right? So what we're going to do is to shift 89 backwards, right, so that we can insert 17. So think of this as having let's say you have some set of books arranged and you want to insert a new book at the center of those books, right? So you're going to have to shift the books backward, right, so that you can insert a new book within the books, right? So that's how this works. Now, since we had to shift all the elements starting from 89, right, the time complexity is linear, so it's big O of n, where n is the number of elements we had to shift. Okay, appending an element to the end of a dynamic array. So let's assume we want to append 9 to the end of this dynamic array, right? So the time complexity is constant because we only have to perform one operation, right? It's just to set the key at that index, set the index, right? Set that index to 9. Okay. Okay, however, there are times we need to double the size of the array, right? As discussed earlier, since the array is dynamic, we might want to increase the size, but this happens rarely, right? This doesn't happen all the time. Therefore, the time complexity is considered constant. Okay. Deleting an element from a dynamic array. So let's assume you want to delete 89. Now, if we delete 89 at index 3, the slot will be empty, right? So the slot will be empty. So we have to cover up that slot because we only want to delete the element, right? But we don't want that index to be empty. Okay, so what we have to do is to move all the elements after 89 forward by 1 to fill up the empty space. Okay, so the diagram is self-explanatory. So since we have to shift all the elements starting from 2 forward, right, the time that should be forward, not backwards, forward, the time complexity is big O of n. Okay, so it's big O of n, where n is the element we have to shift forward to fill up the empty space. So this diagram shows the operations performed on the static and the dynamic array, and it shows the time complexity for each operation. Okay, so the access time complexity, search time complexity, insertion time complexity, deletion, and appending. So in the next video, we're going to be looking at the code implementation of a dynamic array. So we are going to be building a dynamic array from scratch. This is going to be very, very interesting. Okay, so I'm sure you don't want to miss this. Don't forget to subscribe so you can be notified when the next video is out. Thank you for staying to the end of this video. If you have any question, put it in the comment box. I'll be glad to respond to them. If you have topics that we can discuss on this channel, you can also put it in the comment box. Thank you very much. See you in the next video. Bye.